Tonight's lesson is on representing proportional relationships with equations. I'm hopeful by the end of tonight, if you're given a proportional relationship, you'll be able to create an equation that describes that relationship. I just want to remind you, proportional relationships have a constant ratio or unit rate. The constant ratio or unit rate can also be called the constant of proportionality. We normally see proportional equations in two forms. The first form could be y equals some number times x. For instance, y equals 3x. That might mean that you can travel 3 miles per gallon of gas. Another way you might see that same proportional equation would be y over x equals 3 over 1. Those are the two forms we generally see proportional equations. Let's take a look at the first example. Let's read it over together. Do we have enough gas to make it to the gas station? Your mother has accelerated onto the interstate, beginning a long road trip, and you notice that the low fuel light is on, indicating there is half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up her tank. So if you look at the table provided, the mother's gas record, gallons, and then miles driven in the table, that is her log that she keeps. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. You know that if you can determine the amount of gas that her car consumes in a particular number of miles, then you can determine whether or not you can make it to the next gas station. It says find the constant of proportionality and explain what it represents in this situation. So I need for you to pause the video, tell me what the constant of proportionality is, and then explain what it means, and then come on back. Okay, to find the constant of proportionality, we know we will simply need to take our number of gallons and find some constant value such that when we multiply our number of gallons by that constant value, we get the corresponding miles driven. So you need to say 8 times what is 224, 10 times what is 280, 4 times what is 112. You know we have a strategy. If you can't quickly come up with what to multiply by, you can always take the miles driven, our dependent variable, and divide by the number of gallons that you have in your car, the independent variable, and that will give you the value to try every time. So I'm just going to take the 224 miles, and I'm going to divide by 8 gallons, and I'll see how many miles I can go on just 1 gallon of gas. So if I take 224 on my calculator and I divide by 8, I come up with 28 miles in 1 gallon of gas. So I can go 28 miles on 1 gallon of gas. And then you're just going to want to double check. What's 10 times 28? Sure enough, that's 280. What's 4 times 28? Sure enough, that's 112. That tells you this is a proportional relationship. We can find the constant of proportionality. In this case, the constant of proportionality, that constant that you multiply, is 28, and it means you can travel 28 miles on 1 gallon of gas. That's what this constant of proportionality means in this example. So you can travel 28 miles on 1 gallon of gas. So what I want you to do now is I want you to try to write an equation that relates the number of miles driven to the number of gallons of gas. So take a minute, pause the video, try it out, come on back. Okay, hopefully you pause the video. You'll remember our constant of proportionality is a 28. So that means that if we take our number of gallons and we multiply by 28, our constant, we're going to get our number of miles driven. Now, I'll tell you, a lot of times they'll create variables. I'm going to say G is for gallons and M is for miles driven. So instead of number of miles times 28, or number of gallons times 28 is your number of miles driven, you could do G times 28 gives you M, your number of miles driven. I'll also tell you, oftentimes we write our constant first. So a lot of times we put our constant before our variable. So that's 28 times G equals your number of miles driven. And there you have it. your equation is 28G equals M, and you would just want to say let G equals number of gallons and let M equal number of miles. Just so if somebody takes a look at the equation 28G, they can see G is gallons, M is miles. There's your equation. Next question. Knowing that there is half a gallon left in the gas tank when the light comes on, will she make it to the nearest gas station? Explain why or why not. Pause the video, try it out, come on back. Okay, for me, I'm going to just use our 28G equals our miles driven. So she has half a gallon left. So I'm going to do 28 times our number of gallons left. You could do 1/2 or you could choose to do 0.5. 28 times 0.5 on your calculator will give you 14. So 14 miles is how far she can go on half a gallon. Well, we know the nearest gas station is actually 26 miles away. So will she make it? No, she will not. She will not make it. She has 14. She can drive. She can go 14 more miles on half a gallon. So she won't make it to the gas station. She won't make it to a gas station 26 miles away. So sadly, on the beginning of their long road trip, they are going to need to call AAA to help them out. It says, using the equation you found in part B, determine how far your mother can travel on 18 gallons of gas. So pause the video, try it out, come on back. Okay, hopefully you paused the video. Our equation is 28G equals M. Now they do ask that you use the equation, so I'm going to, and then I'm going to try to show you another alternative if you're not yet comfortable with these equations. So how far can I go in 18 gallons of gas? Well, I go 28 miles on each gallon, so 28 times 18. And I would just go ahead and use my calculator. 28 times 18 gets me to 504 miles. I can go 504 miles on 18 gallons of gas. I can tell you, if you're not comfortable with the equations yet, you can always use our unit rate or a constant of proportionality, which was 28 miles per gallon of gas. I tell you, you have 18 gallons and you want to know how many miles you can go. You can always set up a nice unit rate, 28 miles over 1 gallon. How many miles for 18 gallons? Well, you take a look at your denominator. 1 times what is 18? Well, 1 times 18 is 18. So you say, if I'm going to multiply my denominator by 18, I need to also multiply my numerator by 18. 28 times 18 does give you your 504 miles. So if you're not yet comfortable with the equation, you can go ahead and use equivalent ratios that we've been working with since the beginning of this unit. Finally, for this example, it says, using the equation found in part B, determine about how many gallons of gas you would need to travel 750 miles. So it says about how many, so you'll be estimating at some point. Take a minute, pause the video, try it out, come on back. Okay, again, I'm going to go ahead and use 28G equals M. 28 times our number of gallons equals M. This time I tell you we're dealing with 750 miles. So then I have 28 times how many gallons will give me 750 miles. If I want to solve for G, I just say 28 times G is 750. How do I undo multiplication? I'll undo multiplication with division. To get G all by itself, I'll need to divide out by 28. If I'm going to divide out the left side of the equal sign by 28, I'm going to divide out the right side of the equal sign by 28. 750 divided by 28. It comes up with this beautiful 26.78571, and on and on and on. I don't know. But it said about how many gallons? So it's between 26 and 27 gallons. If I underline the place value, I look to the right. If it's 5 or more, you add 1 more, and then you kick the rest out the door. So I'm going to say we need about, use the little swivel lines for about, swivelly equal signs for about, 27 gallons of gas to travel 750 miles. So hopefully that's what you came up with. I'd like you to study the following equations. Circle any equations that represent a proportional relationship. Take a minute, pause the video, come on back. Okay, this one doesn't have a y and an x, so that doesn't even have a possibility. Y equals 4x, y equals some constant times x. Definitely a proportional relationship. That could mean something like $4 per pound of coffee. Y over x equals 7. That's absolutely beautiful. Another proportional relationship. If you have your dependent over your independent variable equals some constant, that's a proportional relationship. Y equals 4x plus 3, certainly not a proportional relationship because of that plus 3. Y equals 4x squared, nope, it's got to be in the form y equals 4x. So y equals 4x squared doesn't work. How about x equals y? Well, sure it is, because that's the same as y equals 1x. So that's another beautiful proportional equation. Let's take a look at one more example. Andrea's portraits. Andrea is a street artist in New Orleans. She draws caricatures, cartoon-like portraits of the tourists. People have their portrait drawn and then come back later to pick it up from her. The graph to the right shows the relationship between the number of portraits she draws and the amount of time and hours needed to draw the portraits. Write an equation that would relate the number of portraits drawn to the time spent drawing the portraits. So I'd like you to go ahead, pause the video, try it out, come on back. What I would do if I was trying to figure this out, I would try to look at some nice values, like this value right here. 2 hours to complete 3 portraits is a nice value. Right here is another nice value. 4 hours to complete 6 portraits, and this one looks nice too. 6 hours to complete 9 portraits. And what I can do to find my constant of proportionality, I can do my y over x, my dependent over my independent, which is your number of portraits, over your time in hours. So I can choose any one of those. I'll do 3 portraits in 2 hours. Then I can divide that out to figure out how many portraits per hour. So I can do 3 divided by 2. And what that means is that I can produce 1.5 portraits per hour. And so this is totally a beautiful proportional relationship. It's a nice straight line that goes through the origin. And what I would want to say is, they use T with N. So if I know it's 1.5 portraits per hour, that would be 1.5 times your number of hours, your time, equals your number of portraits. There you go. That is your beautiful proportional relationship. You just take your constant of proportionality times however many hours you want to put into the equation, and that will give you your number of portraits. We can try this out to make sure if we put 4 in place of t, we come up with 6 for our n. So let's just try that. 1.5 times 4 hours. Let's see what we come up with. 1.5 times 4 is 6. We'll give you 6 portraits. And that's how you can always handle this. If you want to try this, you can put 6 in place of t, and you'll find out that you get 9 in place of n. So that's a beautiful equation. For tomorrow, I'd like you to answer this focus question and bring you right up to class ready to share. How can you tell if an equation shows a proportional relationship between 2 quantities? Also, how can you identify the constant of proportionality in an equation that represents a proportional relationship? So take a little time, do a nice write-up on that. We'll pull a card tomorrow. You'll come up and share. Have a good night. Thanks.